How could you run other processes on your computer from within Python? For example, what if from within your Python program, you wanted to launch another program and pass it inputs and capture its output? For this, you need the subprocess module. We're going to focus on starting up other processes that may not be Python processes, communicating with them and handling their output. We're not going to talk about the related topics of concurrency and parallelism. For those, you can use Python's multi-threading, multiprocessing, or concurrent.futures modules. We're going to focus on spawning subprocesses. A subprocess is a process that our program starts up and has control over. By default, subprocesses inherit the environment of our Python process. To run a process, we can use the subprocess module's run function. Here we're running the git command to list the branch names. When we run this program, we'll see that our Git repository has 2 branches. Python also has an os.system function, as well as a subprocess.popen function. The os.system function is less flexible than subprocess.run, and subprocess.popen is a lower-level function. There are times that you may need to use subprocess.popen instead of subprocess.run, but I very rarely need to use anything but the run function. We'll be using the subprocess.run function because it's a high-level API that makes some things a lot simpler than those other alternatives that are included in Python. The run function requires that we pass it one positional argument. By default, that argument is expected to be a list of command line arguments. This list indicates the process to be run and the arguments to pass to that process. If we pass shell equals true to run, then that first argument is expected not to be a list of arguments, but to be a single string that represents the program to be run along with the arguments to be passed in. This is similar to the syntax that we would use if we were calling this process ourselves from our system's command line. By default, the run function doesn't capture the output of the subprocess, so any output that the subprocess generates is shown in the terminal window, just as if we ran the process from outside of our Python process. If we wanted to capture the output of the subprocess, we could pass the capture output equals true argument. Now, the output of the subprocess isn't shown in the terminal. Let's modify our program to capture the output that the subprocess.run function returns. Now if we run our program in interactive mode to drop into a Python REPL after it runs, we could look at that process object that subprocess.run returned to us. This is a completed process object. We could look at the output of our subprocess by axing its stdout attribute. By default, this object will be a bytes object, not a string. Assuming the program we're running gives us text, we probably want text instead of bytes. We can automatically decode the output of this process using the default character encoding by specifying text equals true when we call subprocess.run. Here's a more complex version of our program that captures the output and decodes it into text. Our program now tries to guess the default branch name for our current repository by checking for a couple common names. In this repository, it guessed that main was the default branch name. What if the subprocess has an error while we run it? For example, what if we ran our git command outside of a git repository? The git command shows an error in this case, but our program doesn't show an error, at least not a very appropriate error. It would be nice if we had some way to check whether the subprocess exited successfully or with errors. For most processes, you can do this by checking its exit code, also known as its exit status or its return code. We can use the return code attribute to look at the exit status of our process. Here we're checking for return code that's not equal to 0. If the return code is 0, then the process ran successfully. But if the subprocess returns an exit code that's not 0, that indicates that something went wrong. Now if we run our program again, we'll see the error that the git subprocess gave to our process. What if we only want to continue onward if the subprocess exited successfully? Well, the run function has a check argument for that. If we set check to true, then an exception will be raised if the subprocess exits with a non-zero return code. Now when we run our program, we'll see an exception raised whenever the subprocess experiences an error. When I need to run multiple subprocesses within the same Python script, I often find myself passing the same keyword arguments over and over to the run function. Instead of calling subprocess.run over and over with the same keyword arguments, I often make my own custom run function. This custom run function accepts any number of arguments and raises an exception if the subprocess experiences an error. Here's a different custom run function. This version also captures the output and ensures that the output is text. Here's a version of our Python script that uses this custom run function. If you find subprocess.run to be a little too verbose, you might consider writing a wrapper function or two for your own use cases. When you need to launch a subprocess from within Python, I recommend using the run function from Python's subprocess module.